Hello everyone and welcome back to my YouTube class again. This is the third lecture on this chapter, light reflection and refraction. In this lecture we are going to cover some important terms related to spherical mirrors. Here we have 9 terms, 9 important parts of a spherical mirror. I'm going to explain these points, okay, these important terms. Here we have blank space to explain all this thing. First important terms we have aperture. What is aperture? Let's draw a mirror first. You know, spherical mirror, we have two types of spherical mirror. One is concave mirror. In the concave mirror, the reflecting surface is curved inwards. In case of concave mirror, a reflecting surface is curved inwards, and in case of convex mirror, reflecting surface is curved outwards. Okay. Here we have aperture. Let's discuss in concave mirror first. Here we have concave mirror. Let's say this is our concave mirror. Since this side is non-reflecting surface. Okay, painted surface. Usually this mirror is painted by lead oxide or mercury. Okay, looking mirror te in nadar lang te po hi anung lampang paint na kha mercury ni lo chuan lead oxide mo engma jok jok khaman ani thina chuan reflection fight takin siam thaya. But here in case of concave mirror, see the reflecting surface, width of the reflecting surface ange a reflect hai na chin mo. Let's say this is M, and here we have M dash. Okay, heti chen hi mirror hemi hian in aron reflect hai ni mo. Hemi soina hi hemi in kar ja jong width of the reflecting surface is called aperture. Heta aperture number 1 na kan nei hi ni tani a zau zong mirror reflecting surface zau zong mo kha aperture kan ti chu ani. Width of the reflecting surface of a mirror is called aperture mo. Then number 2 we have pole. Okay, ta hianin concave mirror che ka mang convex mirror a ve thung hin ting in concave ha khanin in case of concave the reflecting surface is curved inwards ka ti hai achung lampang tian aron khwar ta mo fian angin ani chu a khwar lampang kha reflecting surface ania apong lampang hi non reflecting surface kan ti khamo painted surface kan ti khani. But in case of convex in case of convex mirror, reflecting surface is curved outwards aron pong chuaka. Then the non-reflecting surface is this side achung lampang kha mo ta hen spherical mirror logic taila. Here we have a spherical mirror. If you cut this spherical mirror tian kan lo kat ta, you divide it into two. Heti lampang part hi this part is called convex mirror, since our reflecting surface is curved outward aron po na wangin mo, and then this part is called concave mirror. This is convex and this is concave. Okay, then in this case, in this convex mirror, aperture will be M dash. Okay, width of the reflecting surface is called aperture, as I said earlier. Tapo hianin hemi zau zong soina kha aperture chu ni mai mo mirror zau zong ani chu. Then next we have pole. What is pole? Again, let's erase this all this do rab potila. Okay, pole. Here we have concave mirror, and here we have convex mirror. Let's discuss concave mirror first. In case of concave, non-reflecting surface is this side, and the reflecting surface is this left side. Then here, this is called aperture, M dash. Then pole is the midpoint of this reflecting surface, or we can say it is the midpoint of the aperture. Aperture alai takha midpoint ani chon helam le helam hi anin equal to dinan chama. This is called aperture. In case of convex also, aperture, let's say this is M and this is M dash, or we can say this is aperture, and midpoint will be here. This point is called pole. Okay, distance between this and this should be same. This is called pole. Then next we have center of curvature. Okay, center of curvature. Let's erase this. Center of curvature. Yes. Here we have concave mirror. This side is non-reflecting surface. We call it M and M dash. This is aperture, and the pole will be here at the midpoint of this aperture. Alai takhanya. Then your center of curvature, since this is part of spherical mirror, sphere to your sphere will be this. Then the center of this sphere ka circle angin hisab dalah ngai tu atal mo. Alai tak a center ka. Suppose this is the center of this sphere, and then this center is called center of curvature. Center actually this part is not required. Okay, since this is mirror, concave mirror ni wangin, only this center, a center level ka imaginary in ti tu atak takin kanwa depict hello ma imaginary. Then this is called center of curvature. Next, okay, in case of convex akan lo ngai to le taila. Here in case of convex, your center of curvature will be inside the mirror. This side reflecting part, then this side non-reflecting part. In case of convex mirror, your center of curvature is inside the mirror or inside or yang non-reflecting surface lama. Then next is radius of curvature. You know radius to yang center of curvature to this pole. Okay, here hey pole kan tia p ma pole nya hey center of curvature kan tia. The distance between center of curvature and pole is called radius of curvature. Here also you will have pole, and then this is C, so this distance is called radius of curvature. It is denoted by capital R. Okay? This is radius of curvature. The next, principal exists. Principal exists here. This radius of curvature, if you extend toward this, or you can say a line which joined pole and center of curvature is called principal axis. Radius of curvature I hianin I mean line thau hian ya ma se hi I hianin a sei tur ni radius of curvature hi center of curvature le pole hi arin zom ve thau ti se tur. This is radius principal axis ma. Principal axis is a line, imaginary line, which pass through center of curvature and join the pole. Okay, pole what situ khani me. Here also your center of principal axis will be this line. Then next is normal. Okay, normal. Here we have normal. Suppose incident ray. This is, let's say this is our incident ray, which is coming parallel to the principal axis. And then at the point of this let's say this is the point where it strikes a mirror avato analai katila hinita se. So have a reflecting surface at this point. Your mirror is since it is spherical, a sphere ani wangin a reflecting surface akha nge heti hiong hianin tizong hin normal kom don. Since this reflecting surface and this normal should be perpendicular. It should be perpendicular. Perpendicular means they should be 90 degree. Okay, here also your reflecting surface is this, and the incident ray is this line is incident ray, and your normal will be this line. Okay, this is normal. Then what else? Focus. We'll explain focus again. Yes, this is our mirror. This is our incident ray. Whenever an incident ray goes parallel to the principal axis, after reflection it will reflect back and pass through this focus. Principal focus hianin aron kaltang nge ni if our incident ray travels parallel to the principal axis. Principal axis hi parallelin incident ray khalo kalta se principal focus hi kaltang nge ti retur. Or we can say its symbol is f mo. We can say focus or focal point is the midpoint of radius of curvature. It means this side and this side should be equal. Pole atanga focal point length le focal point atanga center of curvature in carlet zone a length ka equal to tinanich distance the midpoint of radius of curvature. We can say midpoint of radius of curvature is called principal focus, where all the incident lights traveling parallel to the principal axis after reflection pass this principal focus. Then next, focal length. Focal length is the distance between this principal focus and pole. Principal focus le pole in carlet zone ka focal length too. In this case, our focal length will be this and this pole. I mean carlet zone. Okay, let's rub this. Rub tentaila. This is F. So focal length will be this and this point. Okay, this is called focal length. Then what else? Focal plane. Focal plane is a line which is perpendicular to the principal axis at the principal focus. Tilaya ngil takarin kaltang khan mo. Perpendicular means this principal focal plane and the principal axis should make 90 degree. 90 degree in CM turni. So this is our focal plane in this case. Okay. A concave mirror B ka chau ni kan considered mo. Convex mirror pokhan tiang thau hinia nakina chir de karon soile thau nga tun video chuan tizong hini sela Hian, we have 9 important terms related to spherical mirrors. All these important terms, each definitions are available in the page number between 3 and 5. You will see this aperture, pole, center of curvature, radius of curvature in page number 3 to 5. So you have to write down all this definition in your notebook, and you have to send it to me before 7 p.m. Thank you.